फिजिक्स का पहला चैप्टर मोशन हम लोग स्टार्ट करने जा रहे हैं। तो सबसे पहले हम ये जान लेते हैं कि मोशन क्या होता है। अ बॉडी सेड टू बी इन मोशन व्हेन इट्स पोजीशन चेंज कॉन्टिन्यूसली विद रिस्पेक्ट टू अ स्टेशनरी ऑब्जेक्ट टेकन एज रेफरेंस पॉइंट। दैट मीन्स कोई भी चीज़ जो हिलती डुलती रहती है या फिर कोई भी यानी कि चीज़ वन प्लेस टू अनदर, एज अ एग्जाम्पल ले लो मूवमेंट। तो यानी कि एकदम मूवमेंट जो करता कोई भी चीज़ कर रही हो उसे हम मोशन कहते हैं। चलो ये तो हो गया बस। अब मोशन के कोई एकदम मस्त एग्जाम्पल देखते हैं।
Observe the conversation between two persons who stand beside a river. What is the state of motion of the mountain? It is at rest. What is the state of motion of the boat? It is moving due south. What is the state of motion of the persons in the boat? They are also moving like boat. How do you decide that the boat and the persons in the boat are moving? With respect to us, the position of the boat and the persons are changing with time, so they are in motion. Now, observe the conversation between the persons sailing in a boat. What is the state of motions of both the persons who stand beside a river? They are moving due north. What is the state of motion of the mountain? It is also moving due north. What is my state of motion? You are at rest. What is the state of motion of the boat? It is moving due south. From the discussions, it is clear that the motion of an object depends on the observer.
इस एग्जाम्पल से हम लोग को ये पता चला कि जो ये नाव में बैठे हुए जो लोग थे उन लोगों को लग रहा था कि जो ये दो लोग यानी कि चल रहे हैं, लेकिन ये ऐसा नहीं था। बल्कि हम लोगों के रियल अकॉर्डिंग ये था कि बोट मूव कर रही थी। ये एकदम रियल एग्जाम्पल था। तो बढ़ते हैं अपने नेक्स्ट टॉपिक की वो डिस्प्लेसमेंट एंड व्हाट इज़ द डिस्टेंस। सो पहले तो मैं ये क्लियर कर दूं कि इसकी यानी कि डेफिनेशन क्या होती है, ठीक है। और पहले तो मैं ये बता देता हूँ कि डिस्प्लेसमेंट एक लॉन्गेस्ट पाथ और डिस्टेंस इज शॉर्टेस्ट पाथ। नहीं, ये लोग उल्टा हो गया। ये शॉर्टेस्ट डिस्टेंस डिस्प्लेसमेंट होता है, डिस्टेंस लॉन्गेस्ट पाथ होता है। तो मैं डायग्राम ड्रॉ कर देता हूँ। वैसे थोड़ी बहुत हो गया है, कोई बात नहीं। डिस्टेंस का डायग्राम में बना देता हूँ। डिस्प्लेसमेंट शॉर्टर डिस्टेंस होता है, इतना याद रखना। हल्की सी मिस्टेक हो गई है, कोई बात नहीं। और फटाक से इसको रिमूव कर देते हैं। अब ये देखो व्हाट इज़ द ऐसा यूनिट, सबकी एक ऐसा यूनिट होती है। तो अब ये दिमाग में रखना कि व्हाट इज़ द ऐसा यूनिट ऑफ यानी कि डिस्टेंस एंड डिस्प्लेसमेंट। तो इसकी बहुत ही सिंपल है, बस इतना दिमाग में याद रखना कि कैपिटल एम कभी मत बनाना, ऑलवेज स्मॉल एम यानी कि मीटर। ओके, let's see some examples of distance and displacement.
Take a circular object like a ball. Throw it into the air with some angle to the horizontal. Observe its path and draw it on paper. We observed the path taken by the circular object when it was thrown into air and the length of the path traversed by the object. In this activity, we learned that The length of the path traversed by an object in a given time interval is called distance, and the shortest distance covered by the object in a specified direction is called displacement. To describe a physical situation, some quantities are specified with magnitude as well as direction. Such a physical quantity is called a vector. The physical quantity which does not require any direction for its explanation is called scalar. Here, PSQ shows the actual distance covered by an object and PQ is displacement, which is a straight line drawn from initial position to final position of the object's motion. The physical quantity which has magnitude and direction is known as vector, and the physical quantity which has magnitude and do not have direction is known as scalar. Therefore, we conclude that the distance is a scalar and displacement is a vector. The SI unit of the distance or displacement is meter and is denoted by m. In the same way, kilometer, centimeter, etc. are also used to express this quantity. Because 1 kilometer is equal to 1000 meter, 1 meter is equal to 100 centimeters. Drawing displacement vectors. Consider a person standing at point P and moves x kilometers towards point Q located in east along PQ, and then after reaching at point Q, he starts moving along QR a distance equal to y kilometers due north. The actual length of the path traveled by the person to reach point R is the length of PQ plus the length of QR. So, x plus y kilometers is the distance traveled by him. Already we know that distance is scalar quantity and its value can never be zero or negative during the motion of the body. In the same example, join the point P and R to know shortest distance. The length of the straight line PR is the displacement from P to R. Thus, the displacement represents the shortest straight line path between the initial and the final positions. Here, the displacement can be found by using the Pythagorean theorem or hypotenuse theorem. Displacement is a vector quantity and it can be positive or negative or zero. Note: the distance covered and the displacement are time-dependent quantities. Suppose a person again travels from R to P, comes back to the original position. Then the person has zero displacement even though he was moved through a distance. Because the person moves back to his original position, that his final position coincides with the initial position.
So let's we start very interesting topic. What is uniform motion and नॉन यूनिफॉर्म मोशन। जो ये टॉपिक है ये बहुत ही सिंपल है और यानी कि ये पूरा चैप्टर ही बहुत सिंपल है, मैंने पहले में स्टार्टिंग में बता दिया है। तो सबसे पहले स्टार्टिंग करते हैं कि व्हाट इज़ अ यूनिफॉर्म मोशन। सबसे पहले डायग्राम ड्रॉ कर देता हूँ मैं आपको क्लियर करने के लिए, इसको हटा देता हूँ। सही देखो, टाइम डिस्टेंस इसको रिमूव कर देते हैं, ठीक है। अब मैं डेफिनेशन के एक बेसिस पे आपको समझा देता हूँ। अ बॉडी हैज़ अ यूनिफॉर्म मोशन इफ इट्स ट्रैवल इक्वल डिस्टेंस इन इक्वल इंटरवल ऑफ टाइम, उसे कहते हैं नॉन यूनिफॉर्म मोशन। और सिंपल ही है, नॉन यूनिफॉर्म मोशन की अगर आपको डेफिनेशन याद हो गई तो कुछ नहीं करना, जहाँ यूनिफॉर्म मोशन जहाँ लिखा हुआ है वहाँ पे बस नॉन यूनिफॉर्म मोशन कर देना है, और जहाँ पे जो इक्वल लिखा है वहाँ पे नॉट इक्वल कर देना है बस। और इसका ये मीनिंग ये था कि एक जो बॉडी है वो यानी कि इक्वल टाइम में इक्वल यानी कि डिस्टेंस ट्रैवल जो कर रही है उसे यूनिफॉर्म कहते हैं, जो नहीं कर रही है उसे नॉन यूनिफॉर्म मोशन कहते हैं। ये बहुत ही सिंपल टॉपिक था। तो लेट्स वी स्टार्ट आवर अदर टॉपिक। देखो मैंने ये कर दिया नॉन यूनिफॉर्म एंड नॉट हो गया। चलो कुछ हमारा नेक्स्ट टॉपिक है एवरेज स्पीड एंड एवरेज वेलोसिटी। लेट्स स्टार्ट विद आवर यूनिक एनिमेशन।
A and reached point B, which is at a distance of 450 kilometers in 9 hours. Here, the distance covered by the bus in each hour is equal to 450 kilometers per 9 hours, which is equal to 50 kilometers per hour. But the bus does not cover exactly 50 kilometers in each hour, because there may be some variations in distance covered by bus for each hour. So we take average of distances covered by the bus for each hour to decide its average speed. The distance covered by an object in a unit time is called average speed. Let the displacement of the trip in this example be 270 kilometers due southeast. The displacement in each hour is equal to 270 kilometers per 9 hours, which is equal to 30 kilometers per hour. The displacement of an object per unit time is called average velocity. Average velocity is vector and is along the direction of displacement. The quantities average speed and average velocity explain the motion of a body in a given time interval. They do not give any information about the motion of the body at a particular instant of time. Numerical problems. Vinay swims in a 60-meter long pool. He covers 120 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Vinay. Click the tab to view the solution. Instantaneous speed. For example, we can tell the speed of the bike at any instance by looking at its speedometer. The speed at any instant is called instantaneous speed. Definition. If the speed of a body changes continuously with time at any instance is called instantaneous speed. The instantaneous speed at a given point is equal to the ratio between sufficiently small distances over a part of the path which contain the reference point and the corresponding small time interval. Speed and velocity. Every object in motion has both velocity and speed. Consider a car moving along a straight road with varying speeds. The motion of the object can be described using distance versus time graph. In this graph, time is taken along the x-axis and distance is taken along the y-axis. From the graph, it can be observed that in time interval t1 to t2, the car traveled a distance equal to s2 minus s1. Then the average speed of the car is s2 minus s1 by t2 minus t1. Speed gives the idea of how fast the body moves. In general, bodies move in a particular direction at an instant of interest, and this direction may not be constant throughout the journey. So, we need to define another quantity called velocity. Velocity gives the idea of how fast the body moves in a specified direction. So, it is a vector. vector can be represented as a directed line segment. Its length indicates magnitude and arrow indicates its direction. If a body moves in a curved path, the tangent drawn at a point on the curve gives the direction of velocity at that instant. Let us perform an activity for observing the direction of motion of a body. Click each tab to know more. Take an object which is tied to the string at one end. Try to rotate the string in a horizontal direction as it makes a circle. Now, release the string at any point on the circle. Observe the direction of motion of the object. Repeat the same procedure for different points. We will observe that the object will be moving in a straight line with respect to the released point. Similarly, we also observe that the direction of motion changes at every point when the object was released. From this activity, we learn that on being released, the object moves along a straight line tangential to the circular path. This is because once the object is released, it continues to move along the direction it has been moving at that instant.